3 minus x is 4 minus u squared. I'll put a box around that because that's also useful. And so that whole thing was just sort of side calculation algebra in order to be sort of prepared now to do these substitutions. And okay, well, what happens? There's this 1/2, which is sort of doing nothing. Dx, I just calculated as 2u du. And root 3 minus x is root that, so root 4 minus u squared, and root x plus 1 is just a u. Okay, so, wow, amazing. The u's cancel, the 2's cancel, and okay. Let's change the limits right now as we go. When x is 0, u is 1, and when x is 1, u is root 2. So anyway, this whole thing just becomes, if I did this correctly, the integral from 1 to root 2 of du over root 4 minus u squared. And now I would classify this problem as just sort of easy, or, well, a problem we have done before. In fact, I just did it a couple minutes ago, and I'm getting a little sick of this. Factor out of 4 inside, and that's 1 minus u squared over 4. Taking the 2 out gives me integral from 1 to root 2 of 1/2 du over root 1 minus u over 2 squared. I do another substitution of w equals u over 2, so that dw is 1/2 du, which is right up there. And now my last sort of thing, I need to change the limits. This is dw over root 1 minus w squared, and when u is 1, w is 1/2, and when u is root 2, this is root 2 over 2. And so this problem just becomes arc sine w, but evaluated at root 2 over 2 and 1/2. Whew. What's the arc sine of root 2 over 2? Pi over 4. What's the arc sine of 1/2? Pi over 6. And so this is just a fourth minus a sixth. So, whatever that is. 3/12 minus 2/12 is 1/12. This whole problem is just pi over 12. That was so exciting, and it is the right answer. Okay, so this was, once again, a bunch of mindless, I don't want to say mindless, but it was just a bunch of just doing a lot of algebra, doing a lot of antidifferentiation, doing a lot of integration. And if you can do all this, then you're just very, very skilled, and now you can just relax and don't have to worry about anything, and you can just kind of solve your problems. I think the previous video, well, I'll stop there. Goodbye.